A lot there. Let's go to barrel lengths. This one should be a little quicker. So what, in general, barrel lengths and why? So, I mean, in my experience from a precision shooting perspective, a very short barrel can be very precise and very accurate. Now, you lose velocity, but barrel length does not necessarily determine accuracy unless it also is a component in your sight radius. So if you're using an optically sighted rifle, a 10-inch barrel can be just as accurate as a 20-inch barrel.
Well, you covered it all.
Oh, okay. No, but so why would you pick these as a person? What's the? I mean, like, for example, I'll throw one more out there and then you go. Yeah. But like the 14.5-inch barrel length, I've come to find, and this is really surprising, where they came to with that, as I understand it, is there were 10-inch barrels with the 10.5 with the GAU and some of the early carbines, and they had these sound dampeners on there because they were so loud they would just rupture your eardrums to fire it. And 14.5-inch actually turned out to be the length in which the gun didn't hurt your ears so badly when you fired it, and that's literally where they got to that number. It wasn't scientific.
Yeah, a fantastic piece for somebody to go research on that. But to answer your question, all things being equal, a shorter barrel is going to be more accurate than a longer barrel. Oh, I know. I said it.
Because it's more rigid, right? It's more rigid. There's less flex.
That's exactly it. The longer the piece of steel, the more weight that is hanging off of your pivot point, which is typically on a free-floated barrel right back at your chamber. So the longer this gets, the more force is being put on this point, causing the barrel to droop. And it's the more weight that this portion of the steel has to support during the firing process. That said, you can make long barrels very, very, very accurate. Look at .338 Lapua barrels at 28 and 32 inches. You absolutely can. So then it becomes, the battle of how much weight do I want to put it at and how much rigidity do I want to put it at versus the velocity that I'm going to gain out of the distance. So it's really interesting when you start talking about why would you choose a set length barrel. What I've always told people is choose the shortest barrel for your given application. One, you're going to appreciate not having the extra piece that you could bang into something when you're trying to carry the rifle. Two, you don't have the weight and everything else that goes along with that. But 5.56 is especially sensitive to, or anything that's small bore, high velocity cartridge is going to be very sensitive to the length of the barrel. So 5.56, as we know, was designed to use a 20-inch barrel. Its powder capacity, its case capacity was designed to fully combust in a 20-inch barrel. And every time we start chopping it off, you're going to reduce the effectiveness of the base cartridge. Now, we all believe and we know 14.5 and 16 is perfectly comfortable and competent as a cartridge, but you do reduce the effective range of it from a military standpoint. Trade-off to 5.56 is you have more unburnt powder, so it's even louder. And even the difference between a 14.5 and a 16 is incredible to the human ear based off of the amount of unburnt powder that's still left in the bore.
5.56 and 5.45 to that as well are velocity-dependent rounds. So you need so what you're doing is by lengthening the barrel, you're buying velocity, and by buying velocity, you're buying ballistic capabilities at greater distances. Right?
Yes.
So by shortening the barrel to a 14.5 with standard 5.56, and I'm talking 55 grain, 62 grain, you're ballistically capable. I mean, you can hit stuff, but you're ballistically viable out to what, 300-400 yards, maybe 5 if you're really pushing it. But with a 20-inch, you can go much further than that. And if you change the cartridge to like a 77 or 75, you're changing that game entirely again.
Right. When you start getting into the design of cartridges, it's another phenomenal conversation. But you have a 5.56 only has a certain amount of surface area that you can impart force into the projectile as it travels down the barrel. The larger the diameter of the bullet, the more force that you can put upon it easier compared to the smaller diameter cartridge. That's why 300 blackouts, you start having a law of diminishing returns after 10 inches for that particular cartridge. So you're able to get more power into it in a shorter distance by using a larger diameter round.
Oh, that makes a lot of sense. I didn't even think about that, but that's completely logical. So the smaller surface area of the caliber of the round you're firing means that there's more pressure behind it to get it down the barrel. If you have more surface area, you're inducing less pressure down the barrel, and so the PSI changes when you go to smaller, higher velocity cartridges.
Yep, that's exactly it. That's why 300 blackout is a shorter length gas system, is because the pressure that exists behind the round is less than the comparable 5.56. That's why you always see a carbine length 16-inch 300 blackout versus, say, a rifle length on an 18-inch for a 5.56, is because that operating pressure inside the pressure containment vessel, the barrel, is too low to operate the mechanism, or is it the right place to operate the mechanism?
So the right answer on barrel length, as I think I'm repeating you here, is you get the shortest barrel you can legally use, legal is part of this, of course, that you can legally use dependent on the goals you have for that gun.
We go into, and as you know from the CMP and the high power world, you want to make sure that your bullet is staying supersonic to the given range that you're wanting to shoot. So that's really kind of the big caveat is where are you going subsonic, meaning where is your bullet going to start tumbling through the air and you lose the base stabilization of the round.
Well, which is true, and actually that was something we worried about at the 600 or 800 yard line, 600 yard line even as well. So for example, you with a short barrel, you may go, or 308 as well, at 1,000 yards, right? I found 175s to say supersonic to about 1,200, and certain 168 grain loads would actually go subsonic around 900 yards. And when you go subsonic, your zero kind of goes to hell because things get weird.
Yep, and the actual effect is going through the transonic barrier, if you've ever heard that term before. That's when you're going from being supersonic on the round to being subsonic. And when the bullet goes through that transition, a lot of turbulence is put on the round itself. That's what causes the destabilization of the round. And it will either, restabilize, but at this point, mind you, it's been wobbling all over the place in terms of the air. So it may restabilize, but it's not going on the exact same azimuth that it was on when it was traveling downrange. So that's why you see now 308s and other guys wanting to really put heavy twists on barrels, is because it imparts more stabilization into the bullet, so it's more resistant when it goes transonic at those ranges.
Yep. Cool. Awesome. And you know what? It's obvious we can have a lot of these conversations because all this stuff could be entire videos, right? Essentially.